there's very strong, compelling evidence at this point that bacteria are the cause of neurodegenerative diseases.
Welcome to the Doctor's Pharmacy. This is Dr. Mark Hyman. That's pharmacy with an F, F-A-R-M-A-C-Y. It's a place for conversations that matter. And if you care about your brain, today's conversation will matter to you because it's with Dr. Jay Lombard, who's an extraordinary physician, neurologist, psychiatrist, author, speaker, and friend of mine who I met probably, close to 15 years ago. I don't even know. It seems like a long time ago. And you were teaching a course on a functional medicine approach to neurodegenerative disease. And
Correct.
Sitting there listening to you, my mind was just completely blown. And we're going to go through what we learned then and what we know now, almost a decade plus later, about how to fix and treat very tough brain diseases, things that there really is no good treatment for in conventional medicine, things like ALS and Alzheimer's, Parkinson's, MS, all these horrible diseases that we really struggle dealing with. So he's integrating a whole series of things that are pretty unusual for a doctor. He's written a book called The Mind of God about spirituality, faith, medicine. He integrates understanding of the biology of our human being, our psychological components, our existential components in a very complete holistic treatment of the person. He's a very unique guy. And he's written a lot about all sorts of things, including the Brain Wellness Program, which was a great book he wrote years ago, which is how I got to meet him. And recently, The Mind of God, which was featured in the New York Times, a great article about you in the New York Times. Very, very good. Congratulations. And exploring the difference and the relationship between faith and science. He's appeared on lots of TV, radio shows, including Larry King Live. That was a while ago.
Yes.
CBS News, the Food Network, Dr. Oz. And he's been the chief of neurology at Westchester Square Medical Center, the Bronx Lebanon Hospital, and clinical assistant professor at New York Presbyterian and Albert Einstein College of Medicine. And he has a practice in Tarrytown, New York, which is fantastic. So welcome, Dr. Lombard.
2 disclaimers. I'm not a psychiatrist, and I really know nothing about the brain.
Oh, wow. Okay. Well, I thought you said you were trained in psychiatry.
I was trained in psychiatry. Yes, I'm not a psychiatrist.
So you're not technically a psychiatrist,
Correct.
But you learned enough about psychiatry.
Just enough to be dangerous.
It's often, psychiatry used to be brainless,
Right.
and now it's mindless.
Right, exactly. Exactly.
So you try to bring those two things together, and I think that's
I tried
awesome.
and failed.
So we were discussing, and we've talked over the years about the challenges of dealing with this sort of epidemic of broken brains, brain disorders that we in medicine really struggle with.
Right.
A typical line for neurologists was diagnose and adios.
Right.
You can diagnose the disease, but not much we can do. We'll see you later and good luck. But now that's all changing. And you're doing pioneering work looking at the relationship between things like inflammation and our gut microbiome and mitochondria and all sorts of stuff that just seems sort of marginal in medicine, but now has come to the center and is allowing us to think about these conditions in a new way. Correct. And treat patients in a new way. Right. And you are at the leading edge of that. You have thought differently about this than almost any neurologist I've met. I mean, we've had David Perlmutter on the show and others, but this is your sweet spot is the sort of intersection of all this emerging science, emerging therapies, and putting them together for patients in a way that really help to make them better. So thank you for that.
That's the goal.
That's the goal. All right. So just to dig in a little bit, let's start at 30,000 feet. Why have we failed so miserably at addressing these neurodegenerative diseases that are affecting literally millions and millions of people in the United States and around the world and causing untold suffering to patients and their families?
That's a very simple answer. We're treating symptoms, not pathophysiology.
So
which is why I love IFM.
Yeah. So functional medicine is really about treating the cause.
Exactly.
And not the symptom.
Right.
That's right. And that's what we're good at in medicine is treating symptoms, but the disease process continues underneath those symptoms.
Yep.
Even though the symptoms are suppressed, right?
Right, exactly.
So it's fine if you have a broken leg and you want to take a painkiller. You don't care if your leg's still broken. You don't want to hurt.
Right.
But for these kind of conditions, we've just spent so much money and research in the wrong direction.
100%.
So what is really the root of these things? You were sharing with me before we got on the show that Parkinson's and ALS and MS and Alzheimer's, there's so much in common. They're almost the same disease with different manifestations, like the same tree trunk with lots of different branches.
Right. That's
So
right.
How does that work?
Well, I think that, there's been a lot of research recently, really quite frankly, from IFM, which kind of led into
The Institute for Functional Medicine.
Right.
Yeah.
Right. That basically talking about, the role of the microbiome in chronic disease. So I'd be honest with you, I was very skeptical of that whole thing until I saw my first patient with ALS who told me that he had SIBO.
Yes.
Okay. And I'm like, okay.
What is that?
Right.
What is SIBO?
I was like, what is SIBO? Like,
You're a neurologist. Anything that happens south of the neck, you're like, what? I don't know.
Right. So I said to him, I go, look, SIBO there, ALS here. He goes, no, my ALS is being caused by my SIBO.
And what is SIBO?
Well, he didn't know. I didn't know at the time what SIBO was. Okay. I got to get to the punchline. So what is SIBO? Good question. So what is SIBO? But I sort of started thinking like a microbiologist instead of a neurologist, meaning that my patient's telling me he has an infectious disease that's associated with his ALS. Since he's one person, instead of trying to divide and conquer that he has, SIBO and has ALS, what if SIBO and ALS were somehow related? That was the first question I started with when addressing this particular patient.
Most people don't know what SIBO is. So what is it?
What is SIBO? It's
Yeah.
small intestinal bacterial overgrowth.
So it means bacteria are growing in your small intestine.
Oh, you asked me that question. You want me to answer that question?
Yeah, because
I'm sorry.
people who knows what SIBO is, right? sounds like a new kind of.
I thought everyone knows what SIBO is.
Isn't that the convenience stores and airports SIBO or something?
Right.
No. SIBO means that you've got bacteria growing in your small intestine, where it's not supposed to be. It's supposed to be in the large intestine, and when you eat food, it ferments quickly and you feel bloated, distended. You get what we call a food baby, and it can cause a whole host of other problems. It's been linked to fibromyalgia, to depression, to heart disease. I mean, pretty much everything, right? So now
I'm thinking about, can a bacteria be the cause of ALS? Now, this is at this point, a completely unfounded theory that, people have told me to this day. I'm still crazy for thinking this. Okay. So anyway,
I don't think so.
Good. So my second patient with ALS had ulcerative colitis and ALS.
Oh.
And I said, oh, this is interesting. So I started looking at ulcerative colitis. And I was like, wow, ulcerative colitis looks like it's immune mediated. Not that it's autoimmune, but immune mediated from bacteria.
Yep.
So I started looking at all this gastroenterology literature about ulcerative colitis and Crohn's. And I go, oh my God, it's the same bacteria.
Yep.
So
I got ulcerative colitis from C. diff.
Right. Exactly.
Almost died from it. And it made my brain not work.
Wow. It's just amazing that you're sharing that with me because, I'm a neurologist. I don't think about ulcerative colitis. I don't think about Crohn's. I don't think about fecal transplants. I don't think any of that, right? All of a sudden I'm like, okay, I'm thrown into this thing where if I believe that C. diff is the cause of ALS, I got to kill this disease, man. I'm like a disease hunter. Like I'm going to nail this disease, right? So what happens? So
you're like the Indiana Jones of medicine.
I'm Indiana Jones of medicine, right? You're screwing my patient. I'm going to get you first. My best friend is like a former FBI agent, so it's like that's like when they follow serial killers, that's what they do, right? They get all the evidence and then they kill them, or they arrest him at least,
yeah.
Right?
First they hopefully arrest him, then they try him,
but
and
in
then
C.
they kill
diff,
him.
you got to kill, not arrest. But that's a whole separate conversation. But anyway, so I started putting together how C. diff neuropathologically can produce motor neuron disease, because I had to sort of establish what those pathways were in order to convince my colleagues that they should look into this.
So
right?
kind of connect the dots between stuff that goes wrong south of the border there in the gut
to the nervous system
and what happens to your brain.
Correct.
But they're actually connected, right? There's a whole thing called the second brain, which is your gut.
Yes.
And your brain, which is your brain.
Right.
And they're all connected through all kinds of hard wiring.
It's one body.
Right.
We're one body. Isn't that holistic medicine?
Yeah,
the idea
right.
that you treat the patient.
That's why I joke. I always say I'm a holistic doctor because I take care of people with a whole list of problems. And they're all connected.
They're all connected. Why?
All connected.
Because you have all those problems, right?
Yeah. I mean, there's this horrible phrase in medicine. It's called comorbidity.
Right.
Which means you have multiple chronic diseases
that aren't related.
Like, you have heart failure and diabetes and hypertension, and you have kidney failure, and you have, this and that, and Alzheimer's. They're not related. They're just happen to be showing up in the same person at the same time. Oh, it's a coincidence.
Right.
Nonsense.
Right.
They're all connected.
Right. Just like it was a coincidence, I was walking down the street and I saw an old doctor who actually, his son was a patient of mine. Like, oh, that's not a coincidence. Like, there has to be something of value for that. But yes, it's not a coincidence that these diseases occur in one person because they're interrelated to each other. So I started asking that question. How are these separate conditions?
What's the mechanism?
What's the mechanism, right? So here's the mechanism. The mechanism is protein aggregation.
That's a fancy word. What does that mean?
Protein aggregation means that chronic disease, by definition, whether it's neurological or cardiovascular even, or even cancer, these are where proteins are malformed. The proteins,
so funny looking proteins.
The proteins have weird
get
shapes.
Damaged.
They're
or injured or produced in ways that are funky.
Right, and that's the common factor in every neurodegenerative disease, meaning that they're misfolded proteins. So
Amyloid and Alzheimer.
Amyloid, tau, alpha-synuclein, all of the different proteins that are associated with their pathology for those diseases. They're all protein misfolding disorders. I said, okay, well, why are they misfolding? Like, what's stopping them from folding properly? And what controls...
because it's not only the amino acid structure of a protein that matters. It's the three-dimensional structure of the protein and how that interacts with receptors and how it interacts with other proteins and how it interacts with your cell membranes.
Everything. It's a three-dimensional world.
Right.
It's not two-dimensional. So I started thinking, okay, what is causing the proteins to misfold? Okay, and I think this is well known. It's not something I discovered, so this is actually well known that misfolded proteins are caused by microtubule dysfunction. And microtubule dysfunction is caused by other things. There's actually lots of things that cause microtubule dysfunction, but guess what bacteria produces primary microtubule dysfunction as its pathology?
C. diff.
100%.
But many other bacteria might do that too?
I looked for that question, and I could not find as strong an evidence of a direct A to Z link between Clostridium. Clostridium actually makes a toxin that you can actually test for called Rho kinase. So Rho kinase, I said, what does Rho kinase do? Well, how is Rho kinase producing the lethality? The lethality, is that the right way?
That's good enough.
Yeah, lethality.
Deadliness.
Deadliness, right, of cells. And it does it by poisoning microtubule associated proteins.
What's a microtubule?
Microtubule is like the architecture of this house. Think about all of the scaffolds and all of the walls. Everything makes this house.
All the framing.
It's the framing of the cell, but more. It's not just the framing of the cell. It's in charge of all of the export import. The border control.
So it's the trading company,
right? And reproduction. I mean, how cool is it? It has that function, right?
Yeah.
It's all about reproduction for microtubules as well. So it has interface not just with ALS, but also cancer. So if you look at the cancer data, these are protein aggregation disorders as well. Different proteins, obviously, right? But possibly the same mechanism of what's causing those misfolded proteins. So I was like, okay, I'm not ready yet for this. I mean, like even this conversation, but I've not begun to look at evidence of C. diff in cancer yet, because right now I have to focus just on neurodegenerative diseases.
Yeah.
But in that case, so we're at the potential, issue that, how do we prove this, basically?
So then what causes, besides C. diff, though, there's other things, right, that cause it, right? Inflammation and...
Well, inflammation as a result of infection.
You're saying there's one cause, which is C. diff for all neurodegenerative diseases?
In order to prove that hypothesis, two things have to happen going forward. Two things. The first is we have to establish that there is C. diff in the brains of patients with Alzheimer's disease. Mm-hmm. Guess what? That study's been done.
Yeah.
It also showed that there was some...
poop for brains.
Poop for brains. Is that a true website or something? Or I thought Rudy made that up. Poops for brains.
Well, there's another way to say it, but
more importantly, clinically, I mean, look, people can say, oh, it's an epiphenomena, right? Like the brain is, already decomposing, and of course you can have the bacteria emerging when the person's dead. Fair argument, right? Maybe it's not that Clostridium is causing the disease, but it's there for the ride as it eats your brain up after you're dead. Right, that's sort of the
meaning they find out an autopsy, but
right.
Maybe
it doesn't mean that it was there when they were living.
Yeah.
Right. So fair enough. That what that means is that we have to demonstrate.
So they ran for the hills as soon as the person died. Is that it?
I guess. I don't know. It's true. Probably unlikely, right?
Yeah, unlikely.
Exactly.
Yeah.
But in fairness to that sort of counter punch, what the medical community would ask for going forward is, especially clinically, like we can make a decision that we think that this is definitely C. difficile in a patient with a disease like Alzheimer's, right? To make that conclusion clinically, you have to have absolute 100% evidence that that bacteria is actually causing that disease. With some,
Yeah.
obviously not every disease is going to, test positive. And not only is the challenge here that the majority of patients who test for C. difficile, who have dementia, Parkinson's, Alzheimer's, and what have you, have negative tests for C. diff.
In their stool.
In their stools, right. And so people that are sort of looking at this picture with me, if you will, are saying exactly that. Well, it can't be C. diff because we're testing C. diff in the stool and it's not there. I say, well, guess what? It went uptown, okay? It used to live downtown, but it likes uptown more. Why? Because A, we give them PPIs, which they love that alkalinic environment.
Acid blockers.
Acid blockers.
Like Pepsid.
Prevacid. And what do we give them that they love most of all? Antibiotics. C. diff loves antibiotics.
It's actually an antibiotic-associated infection.
Exactly.
That's how I got it.
It is,
I took an antibiotic for my bad tooth, and I ended up getting C. diff.
Yep. If that's not a word of warning to all the listeners, I don't know what is. Yes, exactly right. It's called antibiotic-associated C. diff. So I started asking patients with neurodegenerative diseases if they had a prodrome when they first started getting sick. And all across the board.
I mean, like symptoms that happened before they got.
Of course. Well, you ask questions like that, right? I want to know like what they did as a baby, basically. Even though they're 70s old. Why you ask? I don't know. I've asked my mom that question. But, but younger patients, you can ask them that question because they're with their parents. And I say to them, I ask them 3 questions. I go, did you have a lot of antibiotic exposure before you got sick? 100%. It's like I know the answer before I even ask the question. It's just a question of how many antibiotics they had and what course of antibiotics they had. And the second question that's worthwhile to ask clinically is, do you have trouble actually mounting a fever? So that's a question that I was surprised by the answer that most my patients basically have said, no, you know what? I've noticed I really never get a fever. I'm like, oh, okay. So,
which is not necessarily a good thing.
That's right. It's not a good thing at all, because the only thing that actually will treat spores, right, is heat. If you look at
that's why we get a fever, right?
That's why we get a fever.
You get a fever because it's your body's mechanism for killing infections.
It's I make a joke with people. I say to them all the time. I said, name one disease that humans have cured. Like, they always mention infectious diseases because that is the truth. We've cured infectious disease. But the only thing that actually cures disease is our endogenous mechanisms. Fever and sleep basically are the 2 endogenous mechanisms of holistic medicine.
And
right?
endogenous means stuff that you do yourself. Your body does it.
Your body's doing it for you.
Yeah.
But you have to help the body do that. You can't be staying up late and taking PPIs to watch, Seinfeld episodes.
You can't have your pizza followed by your Prilosec and stay up all night watching Game of Thrones.
Correct. Now, in perfect disclosure,
that sounds fun.
I've done all of those, except I actually do eat the pizza when I'm watching those shows, and I know I got to work on myself basically. Okay, doctor, treat yourself.
Yeah.
Right. But anyway, yes.
So this whole conversation is fascinating to me because, from a functional medicine perspective, many roads lead to Rome. In other words, just because you know the name of the diagnosis of the disease you have doesn't mean you know what's wrong with you.
Exactly.
And the truth is there can be 10 or 20 causes for the same disease.
Right.
And I think that's probably true even of neurodegenerative diseases like Alzheimer's. So I just want to make sure that we're not saying that every single person with Alzheimer's has C. diff.
Right.
Or that's the cause, because it could be something else.
Exactly.
It could be Lyme disease.
100%.
It could be heavy metals.
But the point is,
resistance.
But I think the sort of like the devil's in the details, if you will, right? Meaning that yes, I think there's very strong, compelling evidence at this point that bacteria are the cause of neurodegenerative diseases. Not my research.
Rudy. We talked about Rudy Tanzi, who's a Harvard scientist, one of the discoverers of some of the presenilin genes, which are the genes that show that people are at risk for early Alzheimer's. He actually said they were discovering all these microbes in the brain, which we thought was sterile, and that we had this blood-brain barrier that protects us.
Right.
And you're saying, and he's saying that barrier is not always 100%, and that stuff can leak through. Not only can you have a leaky gut, but you can have a leaky brain.
Look, bacteria, not to scare people, bacteria love the brain. Why? 25% of the body's glucose is used by the brain. They know where to eat. They're going to, Le Pen or that fancy restaurant is downtown. Like everyone else is eating downtown. They're getting, our brains.
Can bacteria live on ketones?
100%. But not, wait, that's very important. They prefer simple sugars. Why? Because they're lazy, right? They want instant gratification. So they like sugar better than ketones.
But ketones and ketotic diets work for some of these neurodegenerative diseases like Alzheimer's and even ALS and brain cancer.
That's right. And I think one of the mechanisms, to be honest with you, is that ketones actually improve mitochondrial function, but they're not a good substrate for bacteria. They're a great substrate for us. Bacteria don't like them because they like eating fast food, basically.
Yeah. So feed them sugar and we eat fat.
That's right.
Okay, so this is just a breakthrough idea, and this isn't just an idea. You've actually treated patients using this approach and seen some really extraordinary things.
Yes.
So can you share with us, a little bit about this case you were sharing with me earlier about ALS, which is a horrible condition. Stephen Hawking had it. It was called Lou Gehrig's disease after the baseball player. Essentially, it's where your nervous system is affected by the killing of the neurons in your spinal cord, which makes you basically paralyzed. You got fasciculation, which is twitching. You eventually can't move your arms and legs. You're in a wheelchair. You can't breathe. You need a respirator.
You wouldn't wish it on your worst enemy. You would not work.
It's like a slowly getting paralyzed. Right?
Yep, that's right.
And never has there been a treatment that has stopped or reversed it.
Right.
And you're saying that you've seen patients where this has actually happened.
So, we are in the process of validating that data. Yes.
So, yes, we need more studies. Yes, we need to do research on multiple patients. Right. But even if there's one patient where you've seen a change, it raises the question.
By the way, it's made me go crazy, by the way, because, I'm finally glad to be a neurologist. Being a neurologist is like being a nihilist or a masochist.
Diagnose and adios, right?
Well, it's worse than that. It's like diagnose and let me not tell the patient that they have ALS. Let me treat them for, like a CIDP picture, because they don't want to actually make that diagnosis for people. It's the hardest diagnosis you could make for a patient, because everyone knows ALS is incurable disease, right? I mean, it's 100%. It's like not even pancreatic cancer is better. Well, you have a 5% chance of living with pancreatic cancer. You have 0 chance of living through this disease. 0.
So based on your hypothesis that it's infectious,
yes,
that plays a big role, if not is the main role.
Right.
I personally shared on this podcast that I went to a place in Mexico called Santa Viva, where I and my wife both went through this treatment called hyperthermia, which essentially is where they heat you up to 107 degrees, which sounds crazy and is scary. Right. But actually, we did both fine, and it killed a lot of infections that we had.
Yeah, like it's amazing.
Lyme.
Right.
My wife, her viral loads of very tough to treat infection called CMV came plummeting down.
Yep.
She felt much better. I felt much better. And and so this is a therapy that is not much used in the United States, but is used widely in Europe, is used in Mexico and other countries as a therapy for some of these types of infectious diseases and even cancer.
Right.
So how does the theory work behind this with something like ALS?
Well, the idea is that, fever is the way of actually denaturing spores. So
okay, that's a big sentence. Can you unpack that?
Sure. So human cells have their proteins that either fold properly or not fold properly at a certain temperature, right? Bacteria have their own temperature zone, like their ideal climate, And spores have another ideal climate, right? Meaning that to kill a spore
is like a baby bacteria.
a spore is a baby bacteria. And that's what I believe personally is the reason that patients have amyloid accumulation, that the spores are creating this protective cover against antibiotics that actually is, in fact, the amyloid being produced.
So the amyloid is like the armor for the bacteria.
Yes, they're like the bomb shelter.
Yeah.
It's the biofilm is the bomb shelter for these little baby bacteria. Yep.
And so how does hyperthermia work to disrupt that? And
so
what is that
because
procedure?
So it works. Hyperthermia works by it's a very narrow window of temperature. Meaning, if you give too much temperature, you can actually hurt normal cells as much as bacterial cells. If you don't give enough temperature, you've done nothing.
So it's like Goldilocks.
It's
right?
like Goldilocks.
You got to get it just right.
You have to get it exactly right. Okay, and that's part of the way that the hyperthermia technology has been developed is by really understanding that the brain itself can provide feedback on the tolerability for human cells, because brain cells are going to tell the brain, hey, this is pretty hot in here.
You don't want to fry your brain.
Right. Can you turn the thermostat off now? So the part of the device actually is to get the brain temperature back into the feedback system where it's self-regulating, so that you never reach a point where the temperature is harmful to your own cells.
Mm. And so, they often, in places where they do this, they'll give, at the peak of the temperature, they'll give antibiotics or antivirals.
Right.
Does that make sense?
To give antivirals?
Or, to give antimicrobial treatment to patients when they're at the peak of the fever, because the idea is that it sort of flushes out the...
For acute infection, yes. I would argue
like
that...
Lyme or...
Well, if the Lyme is acute, certainly. I mean, I don't think that I think you got to be weary of the issue that by, robbing Peter to pay Paul, for instance. Let's say that C. diff is, let's for argument's sake say this is a polymicrobial disease, okay? As opposed to
like lots of different bugs.
Lots of different bugs, as opposed to just one ringleader that everyone else is following, okay?
Mm.
So Lombard believes it's that C. diff is the ringleader, okay? And all these other guys, Lyme, HSV, they're tagging a ride because it's such a great killer that it's like, okay, great, we'll take the leftovers, no problem here. We'll take the leftovers. So my concern is clinically that if we start treating patients, with bacterial drugs like Rocephin, whatever it is for chronic Lyme, yes, you're addressing chronic Lyme.
I mean, the C. diff gets worse.
Yes, exactly.
Yeah,
exactly.
So the heat alone is enough to disrupt the C. diff?
We haven't demonstrated that yet, to be quite frank. But what's been demonstrated is that by applying hyperthermia, that we're able to actually see improvement in clinical symptoms of patients with ALS.
So people's muscle strength, this is a progressive disease, so it gets worse and worse and worse. Every visit, they're worse.
Right.
You're seeing patients that it stops or gets better, which never happened.
Correct.
Right. So this is a major breakthrough.
I think so.
Major breakthrough. And this is not something new. This has been around for a long time. And so where in the world is most of the research being done on hyperthermia?
For ALS?
Period. I mean,
most of the research on hyperthermia actually is cancer research. So they call it chemohypothermia. So people can look up a lot of data on how hypothermia affects cancer. But as far as I know, there's zero data until now applying hyperthermia for ALS. We will be the first people to actually talk about applying hyperthermia for treatment of ALS.
And what about things like Alzheimer's or Parkinson's or MS?
Well, the difference in those diseases are that in Alzheimer's, right, it's very difficult to induce hyperthermia in a patient with Alzheimer's disease. Why? Because you need to be compliant. The treatment itself is, it's fairly rigorous, as you know from your
They put me to sleep.
They put you to sleep, right? We don't want to put them to sleep, though, right? Because we're concerned about protecting their brain. So, you have a patient who's got, end-stage Alzheimer's disease, for instance. I don't see how this is going to be helpful for them. But early, 100%. Early. In fact, I will talk later, not about the case now, because we're really just in the beginnings of this case. But yeah, I think it would be applicable for Alzheimer's disease as well.
Have you seen any patients reported or in the literature
definitely not.
Or anywhere?
No.
But you it's a theory.
Yes, still a theory.
And MS? What about MS?
MS, there's data on actually the opposite, right? Which is, how do you induce hypothermia, right? Because in MS, it's it's an inflammatory disease, obviously, right? Which, by the way, I also believe is caused by Clostridium, but not C. diff, where it's especially important to actually identify at that stage that this is bacterial. So I don't know what they're...
So what is the idea with MS? That you wouldn't want to use hyperthermia, that you wouldn't want to use heat because it makes it worse?
Well, because remember, when you heat up a patient with MS, what happens? They usually get worse. So the trick is...
But maybe not enough, right? Maybe it's not enough.
That's right. Maybe you haven't reached the threshold to actually, use the body's fever mechanisms against
Because there's
bacteria.
links to MS and Epstein-Barr virus and other infections. There's links to Alzheimer's and herpes virus infections.
Right. So yes, the whole principle is applicable for all those diseases, but we don't know yet if it is applicable yet until we clinically demonstrate that, right? Yeah, I think that this is going to be a treatment that's going to be very important for a lot of different diseases, Mark.
So there's this whole theory that the body has a mechanism for dealing with this, and it has these own proteins that are produced in response to heat. And they're things we learned about in medical school. They're called heat shock proteins.
And I learned something very important about heat shock proteins from Dr. Lessler, because remember that, people looking at how to induce hypothermia, right? So there's all sorts of research. There's actually even a drug in clinic for ALS that is the mechanism of action is based upon increasing heat shock protein through a pharmaceutical agent. So I was at this lecture, and I thought I knew everything basically, and I learned that actually you can induce.
Because you thought MD stood for medical deity, is that it?
Medical deity. Yes, exactly.
We all got that training.
Yeah.
The truth is, we know close to nothing.
That's why I said at the beginning of this talk. Thanks for inviting me, but I really know nothing. Just disclaimer. But anyway, so yes, actually in MS, the goal is to induce heat shock protein through hypothermia. Hypothermia.
So you get people cold.
Not people, the brain.
The brain.
Right. How do we do that?
Chill the brain.
Chill the brain.
How do you do that?
Yeah.
Ice blocks around the head?
No. No. Well, I'll invite you up, and you could see for yourself what that looks like.
All right. Dunk your head in ice water?
Nope. None of the above.
Okay. So we have to be in mystery here?
A mystery about what the device looks like, you mean?
Yeah.
It's basically the same concept as building a hyperthermia device, except remember now that technology itself was developed basically for anesthesiologists. So this was developed at Yale by Dr. Abreu, who's the person who actually discovered a way of measuring brain temperature objectively, externally. Okay, so that's kind of where this whole thing started from, to be honest with you. And
you don't have to stick an electrode in your brain. You can literally map it out from the outside.
You can map it out from the outside. So the ability to do that now allows a clinician to not only, heat the body to create hyperthermic states, but through other types of modalities to actually cool the brain safely, externally, with in the same way, meaning that you can actually apply a small device to a region of the skin, periorbital location, and you can actually change the temperature of the brain through this what's called the brain thermal tunnel.
And that also creates heat shock
protein 70.
And I
didn't know that until I was in Australia.
That's amazing. So you're hopeful about the future of neurology, it sounds like.
It's the first time I've been hopeful about anything in my life, to be honest with you.
That's a big statement.
Yes. It's true.
Yeah. Well, this is a fundamental shift in our thinking and treatment. And
yes.
So besides treating, for example, these ALS patients with hyperthermia, there's a whole lot of other things you do.
Yes.
What are the other things that seem to be effective or that are working?
That I do?
Yeah.
I'm at the stage of my life where I shouldn't say anything political, but I realize that I can sort of, I have to stay in my swim lane. Meaning, as a neurologist, I always thought like, okay, I'm only going to see patients with neurological problems, and I had to get my head around that. I'm holding myself back from.
There is no such thing as neurology.
There really isn't, right?
We're just one human organism.
That's right. And everyone needs. This is a good motto that my friend Jennifer told me I should put. Everyone needs a neurologist. Right? Would that be a good tagline?
Everyone needs a neurologist?
Yeah.
Because everyone has a brain?
That's right. Right.
Fair enough.
So anyway, so I started thinking about pediatric brain cancer. And I have a very dear friend of mine who I was supposed to meet today, and she lost her son to pediatric. It's called DIPG, which is a brainstem glioma that's inoperable.
It's terrible.
You can't resect out of the ponds. So I started thinking about, okay, well, if we can do this for ALS, let's think about if we can do this for cancer, basically.
Yeah.
But those are very early innings in terms of thinking out what that means.
And what happened? Did you try?
No, nothing yet.
Didn't try.
This is all theoretical at this point. I'm just sharing with you where I'm going with this.
But you take a patient with ALS. So if I, as a functional medicine doctor, would take a patient with ALS, I would look at everything. Because it's a disease of inflammation. It's a disease of oxidative stress. It's a disease of often challenges with the gut microbiome.
Right.
So I would look at everything. Maybe heavy metals are involved. Maybe there's environmental toxins that are triggering it. I rarely think it's just one thing. Like I would challenge you to think, I think it's probably Clostridia and.
Okay.
Right?
Right.
And so what else do you do for these patients besides, thinking about this kind of innovative treatment? Like what are the things that you would do to help?
Well, I'm still thinking about how to eliminate Clostridium, to be honest with you, but orally.
Fecal
right?
transplants.
Well, but okay, so that was the
That's the thing that works. For people who are listening, the disease C. diff is a terrible infectious disease, causes diarrhea, and it kills 30,000 people a year. Most antibiotics are not that effective, and even the ones that work are not really fully effective.
Right.
Whereas when you do a fecal transplant, basically taking the poop out of a healthy person and putting some of this disease, it literally is like 98% effective on the first try.
Right. My concern is that if these infections are primarily colonized bacteria, even if it's not, let's say it's C. diff and H. pylori and whatever other bacteria it is, its fecal transplant may not be the way of addressing C. diff in the ileum. Why? Because the good bacteria they're not really good climbers. They're not good rock climbers. They like hanging out, where they're used to hanging out, right? So you put in a transplant of all this healthy bacterium, they like it. They're not going up north. They're perfectly comfortable going down south, which means that the bad guys may never get a look at the good guys in those patients. So I spoke to this with, of course, FMT surgeons because I wanted to ask them this question. So there's a lot of data for FMT being looked at right now using oral FMT, basically, like
pills.
Poop pills, right? And so I asked the question that a good immunologist would ask them, right? Which is, okay, how do we know if you put a good guy in a bad neighborhood, whether you got it, right? And you know what the answer was? That we've seen exacerbations in our studies of patients with ulcerative colitis when we've tried that.
With autoimmune diseases. Yeah, that's right.
Right. So in other words, this
it's complicated stuff.
It's very complicated. Yep.
So yeah, I remember I had a patient with MS once years ago, and she reported to me, and I think as a doctor, your job is to listen carefully, not to come in with a bunch of preconceived ideas about what you learned in medical school. It's true or not true, because often it's not true. And this patient had an incredible exacerbation or worsening of her MS symptoms whenever her gut started becoming wacky. She started bloating, getting distended, was uncomfortable, and then her MS symptoms would get worse.
Right.
And I was like, oh, this is not a coincidence.
Right.
This is important data.
Exactly.
And I knew if I treat her gut, and her MS got better. Like, I didn't know what I was doing at the time. I just like, well,
right.
I know how to make people's gut healthy.
You're an empirical doctor, right?
So I'm thinking, well, let's try this because it's not going to hurt you and it could help you. So let's see what happens. And it's so striking when you start to apply these foundational principles of restoration of health and balance in the system, all sorts of things get better.
Yep.
And in a way, you're resetting the equilibrium through things like hyperthermia and those kind of treatments, right?
Right. Because at that stage, look.
But you use diet, you use supplements, you use other lifestyle factors, exercise, sleep. Like what else do you do as a neurologist when you see these complicated patients who have all these diseases?
I have a mentor who's now teaching me that. So because quite frankly, I'm in sort of that model, of kill the disease, find the magic bullet, and we're done.
Yeah.
Right. But I understand a lot of what should be done. I can tell you the thing that I'm most interested in as far as neuroprotection. Like say if you said to me that if there's one molecule that you could be king of metagenics or king of whatever that you would promote.
Okay, listen up. This is important, guys. What's the one molecule that will save your life?
Well, no, let's not say that either, because then I'd be sort of in the magic bullet frame.
Of course.
But it's torodeoxycholic acid.
Well, that's a big word. What is that stuff?
So,
can you buy it at the GNC or
I don't know, probably
Walmart?
after this podcast, I'm sure we will. Not with my label on it, by the way. But yeah, so TUDCA is actually something that Rutanzi's studying for ALS. So let's give credit where credit's due.
Mm-hmm.
And what TUDCA is secondary bile acid.
Yeah.
Right.
So bile acids are the things that help you digest fat, but they also where all the toxins come out of your body through your liver, right?
Exactly. And the other...
So this is helping you eliminate toxins?
100%. And the other fancy part of the secondary bile acid is that it's attached to taurine, which is my favorite amino acid in neurology. Whenever I give IFM talks, I say, what's your top supplement that you recommend?
And taurine.
It's always taurine.
Which is very relaxing for the brain. It calms it down, right?
Well, it affects aquaporin receptors, right, which affects sleep.
Yeah.
Sleep hygiene is something that I do educate patients on. So I don't want to think that I'm not totally holistic, because I am. But
what about food, too?
Food, too? Yeah. I think food is...
Bagel Knox.
Bagel Knox. At least
cheese,
only in my own diet. I don't recommend this to any patient, trust me.
Pizza, bagel Knox.
No.
What are we talking about here?
No. No, I think that the ketogenic diet is a very important augmentation strategy for patients with neurodegenerative diseases, 100%.
So have you used it in patients with these diseases?
Well, no, because don't forget, I've only been in practice now for, I only have like 4 patients at this stage of my life.
What do you mean? Weren't you a practicing neurologist forever?
I was, but I left and I did other things in my life, basically, Genimind and things like that. So I'm back clinically really only the last year. So I feel like a student again, which is kind of cool, right? To be like a student.
But you take very difficult cases.
I only take the most difficult cases. If you have like
you're like the Sherlock Holmes of neurology,
right? And yeah, my assistant decided on a Sherlock Holmes, icon for my website. But yeah, you like that too?
Yeah,
you do. Okay.
What about Dr. Watson?
Dr. Watson. Okay, I like that too.
No, Sherlock wasn't his sidekick?
Oh, Watson was his sidekick.
Yeah.
So we'll call it the Watson clinics. People think I discovered DNA. It's perfect.
Or what's on?
The Watson clinics.
That's great. So I think that we're in a real new era in neurology. And
and truthfully, I don't want to be sort of making light of this conversation. As a neurologist, look, I chose the wrong profession, to be honest with you, because I'm a very sensitive person. I take every person's problems to heart, too much so, where I've become depressed when people die with these diseases. And that's a depressing place to be because, I'm blaming myself. It's not my fault that they're dying, right? But I still blame them. I blame myself.
You couldn't fix them.
I couldn't fix them, correct. And so when you say, are you happy now? I am, more than happy, meaning that I finally feel like I have tools to treat patients with these kinds of diseases that will die without treatments, basically. Mm-hmm. So I'm very, very optimistic for patients that have these diseases, especially not that I don't think they're applicable for all stages of these diseases, because I think it's much, much more difficult to reverse a patient with end-stage Alzheimer's than it is, right? I mean, it's almost like, it's like, I'm sorry.
Someone needs a new heart if their heart's all damaged from a heart attack.
Right.
Yeah, it's hard to fix that, yeah.
That's right. But I'm very optimistic, both about, Dale's work on sort of, understanding the risk factors and how to intervene before disease, and also what we can do once patients have, onset of those diseases as well.
So in these conditions, there is a way forward, and the hyperthermia concept is fascinating. How far are we from actually being able to do that in America? It's happening in Europe, it's happening in Mexico at scale. What are the obstacles and opportunities that are ahead in using hyperthermia in neurology and other conditions in America?
Well, I think the obstacles, in my opinion, are to establish clinical validity for these conditions.
Like, are we doing research on it? Is it happening in America? Right?
Research is happening. Yes.
And doctors and scientists are starting to look at this.
Yes.
So how far are we from actually seeing this in the news or as a treatment in America?
Very close.
Very close.
Yeah.
So if you're listening and you know someone with ALS or you know someone with MS or Alzheimer's or Parkinson's, there is hope, is what you're saying.
100%.
Yeah.
Yep.
And in functional medicine, we do make a lot of progress, but I think there are things we just don't know. And I think this whole connection between the inflammatory pathways, the microbiome, and the brain is this uncharted territory that we're now exploring.
Right.
And there are a lot of ways to intervene, including the idea of hyperthermia. There's other therapies, poop pills maybe.
Right.
But, we have a whole new way of thinking about these conditions.
And we always have to, right? Medicine has to be iterative, can't be static.
So let's back up a little bit, because I don't think people really understand how you get a leaky brain and what that is, and how does that connect to a leaky gut, and what are those things?
Right. I was having that conversation earlier today, by the way, so I'm very fresh up on this concept. So leaky gut is both a cause and a consequence of dysbiosis, right?
Which is?
The SIBO, which is small intestinal bacterial overgrowth, which is full of bad bacteria that are looking to make things worse, not only in the gut, but also in the bloodstream.
So dysbiosis is basically your happy garden in your gut has been taken over by weeds.
Exactly.
And it's causing havoc.
That's right. And those weeds...
And it's crowding out the good stuff and causing all kinds of problems.
Right. And those weeds want to grow. And guess what prevents them from growing is the mucosal barrier, right? So like, okay, well...
That's the lining in your gut.
Right. So they basically release, certain protease enzymes that break down the proteins in our gut, so they can actually go into other places looking for their food, or if it's a weed analogy, to grow beyond just the gut.
The little Pac-Man, they chew up,
they're chewing up
all
gut.
the intestinal lining so they can sneak through and get into the rest of the body.
That's right. That's right.
And that doesn't, when you have bacteria and nasty proteins in your blood, your body doesn't like that. And
That's right.
It creates what?
Well,
inflammation.
It produces inflammation, but it also produces disease.
Yeah.
And I'll tell you an interesting story.
Which is secondary to the inflammation.
Right. Right. So one of my interesting stories about ALS is that they asked me, they said, this is like a really crazy hypothesis, right? That somehow Clostridium is causing ALS. I said, I realize it's crazy right now, but it won't be crazy for long.
Well, it's like that guy, Dr. Barry from Australia, who decided that H. pylori was the cause of ulcers.
And I was advised to do the exact same thing. I was like, I'm sorry, I'm not eating Clostridium to get ALS. I'm not that desperate to show that this is the right thing. Howard said he did that for H. pylori.
Yeah.
I'm sure he would say, do not do that.
But people thought he was crazy because it was like, oh, this bacteria was around, just like it's around in Alzheimer's and ALS. And people thought, oh, it's just a secondary thing. It's not the real thing.
Right.
So they kind of ignored it, and they laughed at him when he said, just these bacteria are causing ulcers.
Right.
And
he won the Nobel Prize for
not
that,
only
right?
that, I'm going to prove it to you by drinking a beaker of these bacteria, getting an ulcer, curing with an antibiotic. Right. And yeah, you're right. For that, he won the Nobel Prize.
See, I'm afraid that they won't give me a Nobel Prize unless I do it for myself. Okay. Here's C. diff. Okay,
I skipped that.
Can we speed up Alzheimer's, or whatever else, and then I'll prove it's in my bloodstream or through CSF, whatever biomarker you need to know that I'm infected. No, thank you.
No, thank you. No, that's a little too risky. Yeah,
that's right.
But you can do it in animal models. You can do it in other.
So, right? Well, there are animal models that actually show this. So I think that's already been established as well. That there are animal models that if you give them bacterial infections, that you can recapitulate or reproduce, if you will, the pathological changes that occur in neurodegenerative diseases. So that's already there.
So how does that connect to the leaky brain?
Right. Okay. So let me tell you a little.
This was like in medical school. This was like, this is an inviolable barrier. Like nothing gets through except nutrients,
the blood-brain
glucose.
barrier.
Yeah.
Right. Okay.
Like you've got a wall between
So what people need to understand, and actually when I lectured at IFM, I always talk about this to the practitioners, is that leaky gut and leaky brain are synonymous. They're basically the same anatomical structures that exist both in the brain. It's endothelial cells that
barriers.
It's a barrier, right? And the barrier has exactly the same types of glial cells that regulate what's going in or not. They're sort of the
gatekeepers,
the security guards, right? Saying, hey, bad bacteria, don't go in here. So what happens is the bacteria actually are smarter than us, quite frankly. meaning that I'll tell you how much smarter they are than us by an anecdote, and which is that one of my patients who I presented this theory to said, "Why don't you, if you think that this bacteria is causing ALS, why don't you call the CDC?" I said, "Good idea." So I right. She didn't know that I would actually call when she was in the office, right? But I did. I called.
Great idea.
I said, "Yeah, right, great idea." I called the CDC. Okay, no problem. Ding, 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 ding. So I end up speaking to someone there, and he was very respectful. And he said to me, "I'm going to take this back to my working group, and I'll let you know what they think of your insane hypothesis that C. diff is causing ALS." I said, "Okay, great. Give me a call back, like whenever you feel like it. There's no time for me. It's like."
And did he call you?
He called me back, and this is what he said. He said that the group doesn't feel that C. diff has enough evidence of it being anything other than an enteropathogen. I said, "Really?"
That means it only affects your gut.
Only affects the gut.
Use all these big words I keep having to translate.
Sorry, that's right. But I said, "Only belongs in the gut."
Yeah.
And I said, "Well, how about other Clostridium species? Do you think those are only enteropathogens?" And he said, "No." And I said, "Well, guess what? Neither is C. diff. It's not only an enteropathogen. And the way that it moves from the gut into the bloodstream is through leaky gut." I said, "Have you seen the leaky gut data?" I never heard of leaky gut data. I'm like, "Okay, so let me ask you one last question before I hang up this phone." I said, "Do you not believe that other enteropathogens, like E. coli, can produce meningitis?" So of course they can. I go, "Well, you're just contradicting yourself. You're saying that an enteropathogen can't produce meningitis, and in the same breath you're saying, oh, but of course E. coli is an enteropathogen that produces meningitis. Which way you're the CDC, man.
Right.
I'm just some crazy neurologist. Come on, answer that question." And of course, that was the last time they took any of my phone calls. True.
Well, don't confuse me with the facts, right? When mine's made up.
Yes.
It's tough. Paradigms are tough to break because they're very tough to. And we spent, literally billions of dollars and decades building up a paradigm.
Right.
It turns out to be really false.
Right.
The paradigm of medicine today, which is siloed, it's segregated, it's not understanding these interconnections. And I think we're in this convergence right now, which is super exciting, which is the tremendous amount of understanding we're having about systems biology and what we call network medicine, which I also call functional medicine, the emergence of our understanding of the omics revolution, right? The genomics, the metabolomics, the proteomics, and the microbiome, which is blowing the lid off all of our conception of disease, artificial intelligence, which enables us to gather all that data, we call big data, and crunch it in ways that make sense of it where we can't even see. I mean, the average doctor, you look at your blood work, you got 20, 30 other things you look at, fine. What if I gave you 1 million data points to look at?
Oh, forget it.
The doctor is not going to be able to do it, but a computer can do it. And then you get quantified self metrics where you can measure things that the body's doing. And you put all that together, and it's just changing the way we're going to be practicing medicine going forward. And we're going to be able to sort of make much more rapid evolution of understanding of things like what you're talking about.
Well, I agree, except that I think AI is a double-edged sword, because my concern with AI is that if let's say AI comes up with the ideal formula for, treating every disease, let's say. It's an AI.
You need HI too.
Thank you.
Human intelligence.
We need human intelligence.
Filter, right. It just gives you stuff to think about, and then you have to make your decision.
Thank you.
Right. Yep. I 100% agree.
Yep.
We don't want computers treating us, but we do want them to help crunch the data and look at patterns that otherwise we can't see.
Right.
So all you're talking about is that you've noticed a pattern in the literature that connects bacteria to neurodegenerative disease and ALS.
Right. Yep.
And then you're following that trail.
Right.
And you noticed it, but a computer might be able to notice it a lot faster than you. You just kind of had the luck of the insight, right? But the truth is that we can actually start to use computers to start to look at all this data, map it out, read every study, connect the dots in ways that we just can't.
You're saying AI may help me confirm that C. diff is the root of all these diseases?
Absolutely.
Who do I call?
Who do I call? Ghostbusters.
Watson. We'll call Watson. We'll call Watson.
So this is really an amazing moment in medicine where scientists and doctors like you are starting to connect the dots about diseases that were really hopeless and for which we felt helpless and now are hopeful. So thank you.
Thank you.
So thank you. You're listening to The Doctor's Pharmacy. This is Dr. Mark Hyman. We've been with Dr. Jay Lombard. You can learn more about his work at drjlombard.com. That's drjlombard, Lombard.com. You can learn about his practice in Tarrytown, New York, which I certainly would see him if I had a neurological problem. And you can also get his book, which is called The Mind of God, Neuroscience, Faith, and Search for the Soul, which we didn't have too much time to talk about, but it's a fantastic book that maps out the connections between purpose and meaning and health, which we now know is actually scientifically driving health and disease. In fact, there was an article a couple of weeks ago in the Journal of the American Medical Association said that if you had more purpose in your life, you live longer. Who knew?
Purpose is life.
Yes, purpose is life. So thank you. You've been listening to Doctor's Pharmacy. If you love this podcast, we'd love to have you leave a comment and hear from you. We would also love you to share it on Facebook and social media, Instagram, with your friends and family. And if you subscribe to podcasts, please subscribe to this podcast and listen every week. And we'll see you next week on the Doctor's Pharmacy. Hi, everyone. It's Dr. Mark Hyman. So 2 quick things. Number 1, thanks so much for listening to this week's podcast. It really means a lot to me. If you love the podcast, I'd really appreciate you sharing with your friends and family. Second, I want to tell you about a brand new newsletter I started called Mark's Picks. Every week, I'm going to send out a list of a few things that I've been using to take my own health to the next level. This could be books, podcasts, research that I found, supplement recommendations, recipes, or even gadgets. I use a few of those. And if you'd like to get access to this free weekly list, all you have to do is visit drhyman.com/picks. That's drhyman.com/picks. I'll only email you once a week, I promise, and I'll never send you anything else besides my own recommendations. So just go to drhyman.com/picks, that's PICKS, to sign up free today.